Okay, problem 6. Problem 6 is about power series representation for the function, right? By manipulating a geometric series. So just now, as we discussed, for a geometric series, if it's convergent, then the sum from 0 to infinity is a over 1 minus r. Okay, if the absolute value of r is smaller than 1. Okay, so here, these functions, for example, fx, 4 over 2x plus 3. Okay, as you can see, this function is very, very similar to a over 1 minus r. So we just want these constants on the bottom to be 1. So to achieve that, we just divide both the top and the bottom by 3. So we get this, okay? Then we want it to be 1 minus r. So it is 4 over 3, 1 minus negative 2 over 3x. Okay? So now you can see this is exactly this infinite sum of a geometric series, right? You can see this fraction is equal to this infinite sum if and only if the absolute value of r is smaller than 1, right? So now this is your r. Okay, this is your r, this is your a. So you want your absolute value of r to be smaller than 1. Okay, you want your absolute value of r to be smaller than 1. If that's true, then you can rewrite it as the infinite sum. Okay, as a is 4 over 3 here, times r is negative 2 over 3 to the power of n. Okay, then you can summarize it. Okay, for example, 4 is 2 squared over 3. Okay, here I have a negative 1 times 2 over 3x, right? So I have a negative 1 to the power of n. So I have a 2 over 3x to the power of n. So it's 2 to the power of n over 3 to the power of n times x to the power of n. Okay? Then I can rewrite it as the sum. Okay, so on the top I have 2 squared times 2 to the power of n, so it's 2 to the power of n plus 2 over bottom is 3 to the power of n plus 1. Okay, times x to the power of n. All right, so this is the power series representation. Okay, again, don't forget about the condition. If the absolute value of x, right, is smaller than 3 over 2. Okay, this is from here, right? So from here you get this solution. So determine the interval of convergence. Right, based on this, you can see it's x minus, right, the interval of convergence, sorry, the radius, the interval of convergence. Right, as you can see, the interval of convergence is for x between negative 3 over 2 to positive 3 over 2. Okay, that's the interval of convergence. Okay. So let's do part B. Part B, we have x squared on the top, and I have x to the power 4 plus 16. So again, the first step, I want this constant to be 1, right? So I divide both the top and the bottom by 16. I divide the top by 16, I get this. Okay, I divide the bottom by 16, I get this. Right? So now my top is my a, right? So this is my a. At the bottom, I want it to be 1 minus r. So this is my a, and this is my 1 minus negative x to the power 4 over 16. Okay, again, if my r here, if my r is its absolute value is smaller than 1, okay, then I can rewrite this fraction as the geometric series, right? From 0 to infinity, this is a times 1 over 1 minus r, right? A times r to the power of n, okay? A times r to the power of n. Right. Again, you can simplify it. For example, here it's x squared over 16 times, I have a negative 1 to the power of n here, I have an x to the power of 4n here, and the 16 to the power of n here. So it is, right, n from 0 to infinity, negative 1 to the power of n times x to the power of 4n plus 2 over 16 to the power of n plus 1. Okay, again, if this is true, right? If this is true, so how do you solve this? Okay, so essentially its absolute value of x to the power of 4 is smaller than 16. Okay, so the absolute value of x must be smaller than 4th root of 16, okay, which is 2. So the absolute value of x must be smaller than 2. Okay, so the interval of convergence, okay, so the interval of convergence, it is from -2 to 2. Okay, so let's do problem 3. Problem 3, fx is x minus 1 over x plus 2. Okay, again, you can just treat the top as a, but we can also do this, right? We can also do this. It is just 1 minus, okay, or it is x plus 2 minus 3 on the top over x plus 2 on the bottom, right? So it's 1 minus 3 over x plus 2. So again, for this fraction, I want this bottom to be 1, so it's 1 minus 3 over 2 over, okay, 1. So I want this to be a negative, so 1 minus negative half x. Okay, so now this is my a, this is 1 minus r. So again, I want my absolute value of r to be smaller than 1. Okay, in this case, the absolute of x, it must be smaller than 2. So if that's true, then it is 1 minus the summation of a times r to the power of n. Okay, then you can summarize it. It is this times -1 to the power of n times x to the power of n times 2 to the power of n. Okay, so it is 1 minus summation, okay, -1 to the power of n times, right, 3x to the power of n over 2m plus 1. Okay, so you can stop here. All right, you can just stop here. You don't have to simplify further as shown in the answer. It is already correct. Okay, it is already correct. So if the absolute value of x is smaller than 2, right? So now the interval of convergence, it is from -2 to 2. Okay.